Hello guys, in this video we are going to find square roots of rational numbers. In the previous videos we had integers as the question, like finding square roots of integers. But here there are fractions. So how do we do it now? First thing, you need to remember these two laws of exponents. Root a into root b is root of ab. That means when they are in multiplication, two square roots are in multiplication, we can write them a common square root sign. Same with division, root a upon root b is root of a upon b. So these two root sign will become 1. Same with here. And you need to remember squares of 1 to 15. If you remember this, you will automatically know the square roots of numbers from 1 till 225. So square of 1 is 1, 2 is 4. Same way, 11 is 121, 12 square 144, 13 square 169, 14 square 196, 15 square 225. So on the right side, whichever you are seeing numbers, those are the perfect squares whose square root is an integer. And if you see, if you get a sum, root of 225, you can immediately know the answer is 15. Root of 169, answer is 13, and so on. So you need to remember these two things. Now let's look at this sum. Someone would divide it and then take the square root. But if we divide it, we'll get the answer in decimal, and it will be difficult to get a square root then. So what do? Use this law, the reverse. So root of a upon b, we can distribute the root sign. So we can write it as root of 81 upon root of 121. Now we can find the root of these two by any method, prime factorization, long division, shortcut. But we already know these two are perfect squares. We can see it over here, 81. So root of 81 is 9 and root of 121 is 11. So we can directly write it. So 9 upon 11 is the answer. Next, same thing here, we'll divide the square root sign, 169 upon root of 256. Again, these two are perfect squares. So root of 169 is 13, root of 256 is 16. So you can write 13 upon 16. 16 I have not written, root of 256 is 16. Now, the third one. In the third one, if you notice 104, so we have all these perfect squares. We have 81, 100, 121. There is no 104 coming. Same with 234, it doesn't come. 16 square is 256. So now, what do? We can't use this. We can't separately take square root because there is no integer square root. We can do one thing. Keep them here like this. Keep them under one common sign. We'll prime factorize these both and let's see what happens. So let's do it. 104 prime factorization. It goes with 2. All the prime numbers we start like from 2 we check. So 2 is going. Again 2, 2, then 13 ones are 30. Now for 234, 2 will go. 2 ones are 2, 2 ones are 2, 14, 2 sevens are 14. 117 goes with 3. 3 threes are 9. 27, 3 nines are 27. 3 13s are 13 ones are. So now we have got this 104 is broken down into the product of these numbers. 234 is broken down into product of these numbers. Let's replace them. Let's substitute. So the sign remains the same. Instead of 104, I'm just writing the product of these. We have broken down this big number into this part. So 2 into 2 into 2 into 13. And here 234 is 2 into 3 into 3 into 13. Now we can cancel this. Cancel the 2. We get 2 square upon 3 square, the whole root. Now we can divide the root sign. So we'll get root of 2 square upon root of 3 square. Now what is the answer? 2 is squaring and then we are doing the square root. 3 is squaring and we are doing the square root. So the number will be the same. So this is 2. This gets cancelled out. Root and square get cancelled out. This is 3. This is the answer. Thank you for watching.